Bright Tuty. Every student matters.
Let us see a few questions based on the topic that we have just studied. These are very important questions. First question is, how does the force of gravitation between two objects change when the distance between them is reduced to half? Now students, we know that as per the Newton's law of gravitation or the universal law of gravitation, the force was inversely proportional to the square of the distance. We have assumed that the distance between the centers of the two objects is d, right. Now, what exactly the question says, what exactly the question asks is, how does the force of gravitation between two objects change when the distance between them is reduced to half? Means the distance which we have assumed to be d, now examiner is saying that this d is reduced to half, right. So, we know that force is directly proportional to 1 upon d square or inversely proportional to d square. If d is getting halved, the important thing is the force will be impacted as the square of this change, and when I will do the square of this change, I will just find this keeping whole square, it will become d square upon 4. This 4 goes up. So, f becomes 4 into 1 upon d square. So, the initial force was 1 upon d square, but now by making the distance half, the force is now 4 times, right. So, by reducing the distance between them, the force has increased 4 times. Got it? Fine. So, this will be the impact when the distance between two objects is reduced to half. Let us see the next question, numerical based on the formula that we have just studied. What is the magnitude of the gravitational force between the earth and a 1 kilogram object? Now, I need to calculate the magnitude of gravity, that is F, between the earth and a 1 kg object. So, let the mass of the earth be m1 and the mass of the other object is m2. The mass of the object is given to us to be 1 kilogram and the mass of the earth is given to us in the question, it is 6 into 10 to the power 24 kilogram. Then the radius of the earth is given to us. Now, why exactly the radius of the earth is given to us? The reason behind that is the object is kept on the surface. Now, let this be our earth. Now, the object is kept on the surface of the earth. So, if I want to take the distance between the objects, it will be between the centers of these two objects. And if I talk about the center of the earth, the distance comes out to be the radius of the earth, right. And as compared to the radius of the earth, I think we can easily avoid or we can relate that the radius of this 1 kilogram object is quite negligible, right. So, we take indirectly, we take the distance between the earth and the object center to be actual the radius of the earth, which is 6.4 into 10 to the power 6 meters. So, now all the information is provided to me except capital G, and if capital G even it is not provided, I know the value to be 6.67 into 10 to the power minus 11 Newton meter square per kilogram square. Got it? Now, simply I will calculate the force using this formula G into m1 into m2 upon d square. Again, so F is equal to G into m1 m2 upon d square. Now, putting the values, the value of G is 6.67 into 10 to the power minus 11 multiply by the mass of the first object, which is given to us to be that of earth, it is 64 into 10 to the power 24. This was given to us in the question. it is 6 into 10 to the power 24, right, multiply by the mass of the second object is 1 kilogram, divided by the distance between this object and the earth. From the center, if we are taking, this will be basically the radius of the earth, which is given to be 6.4 into 10 to the power 6, and because we have to take the square of it, so I am multiplying it again another time 6.4 into 10 to the power 6. This was our first step, putting the values. Okay. Now, the second step was removal of all the decimals. I am removing this decimal and multiplying the denominator with 100. I am removing these two decimals and multiplying the numerator with 100, cancelling this 100 and 100 directly. So, what I have got is putting out the values. Now, keeping all the numeric values and 10 to the powers at separate places, I get 667 into 6. This I have taken, 6 I have taken, multiply by 10 to the power minus 11. This circles you are not going to do in the exam. I am just showing so that you are able to relate what values we have taken, so that we should not miss anything, right, into 10 to the power 24, divided by, I will take 64, again I will take this 64, multiply by 10 to the power 6 and 6 I can collectively take as 10 to the power 12. Got it? Now, the next step is once again keeping these numerical values right here and like this only, not yet calculating, multiply by, now taking 10 to the powers, this is 10 to the power minus 11, this 12 when it goes up it will also become minus 12 and 10 to the power 24 as it is. Fine. So, now I will just add up all the powers of 10, keeping this again same, 667 into 6 divided by 64 into 64 into 10 to the power, this is minus 12 and minus 12, this comes out to be minus 23 while adding up, and this is 24. So, it comes out to be 10, that is it. Now, we will calculate this part separately and this will come out to be 0.98 into 10, or I can write this is to be 9.8 Newton. Why? Because this is the force that I am calculating. So, the force will come out to be 9.8 Newtons, right. So, this is basically the force which is exerted by earth, fine, on a stone or a ball or any object of 1 kilogram mass which is kept on its surface, right. Now, this thing, if rather than giving the values we are being asked that what exactly will be the force of earth, this is the force exerted by earth on an object kept on its surface. So, in that case what we will take is F is equal to G, that is the gravitational constant, into m1, let this be the mass of the earth, into m2, this be the mass of the second object, divided by d square. And when we are talking about earth and anything kept on its surface, then the distance will be exactly what? The radius of the earth. So, I can also write the radius square rather than d square, because it is one of the same thing in this particular case where this small object was kept on the surface of the earth, right. So, this may be an expression of the force exerted by earth on a particular object with mass m2 which is kept on its surface. Got it? Fine. Alright. Let us see another question. The earth and the moon are attracted to each other by gravitational force. Does the earth attract the moon with a force which is greater or smaller or the same as the force with which the moon attracts the earth? Why? Now, we have seen that if I am calculating the force exerted by earth, that will be equal to gravitational constant multiply the mass of earth, let it be me, multiply by the second object is mass of moon, divided by the distance between them, square of it, right. This is the force exerted by earth on the moon. Now, if I want to calculate the force exerted on earth by the moon, let it be Fm, then what exactly will be the formula? Once again, gravitational constant multiply by the mass of, now let the first object be moon, multiply by the mass of second object is earth, divided by the square of the distance between them. So, we see that if we relate mathematically also, we see that the force exerted by the earth on moon or by the moon on earth will be equal, right, fine. And why it is equal? Once again, Newton's third law of motion, if you remember, action and reaction are equal and opposite, right. So, they will be exerting an equal force upon each other, clear. Okay. Let us see, if the moon attracts the earth, then why does the earth not move towards the moon? This we have already discussed. Two reasons. First is the mass of earth is too much, the distance between them is too much, right. So, that is why the movement of earth is not exactly visible, that it is moving towards the moon, fine. Now, this is quite an important question. Let us try to relate what happens to the force between two objects if the mass of one object is doubled. Let us take the first case first. We know that the force exerted by any two objects on each other is equal to G m1 m2 upon d square, where let the m1 be the mass of the first object, m2 be the mass of second object, d is the distance between them, right. Now, as per the question, this is actually what normal force should have been. What he is saying is, if the mass of one object is doubled, right, then in that case the force which was initially G m1 m2 upon d square, now let us say that the mass one object, its mass has been doubled, it becomes twice m1 into m2 upon d square. So, simply we can see that the force of attraction will be between these two objects will also be doubled, correct. Second situation, let us see, the distance between the object is doubled and tripled. Now, we know that the force between the objects is inversely proportional to the square of the distance between them, right. So, if anything happens, any change comes in the distance, then the force will be impacted square of it, right. So, the impact will be, effect on the force will be the square of the change. So, if I am doubling up the distance, so that means now in second case it will become 1 upon, rather than writing d, I am writing 2d because it is doubled up, and now because it is whole square. So, it comes out to be that force is inversely proportional now to 4d square. So, if initially it was 1 upon d square, so now by doubling up the distance, I see that the force is basically been 1/4. Similarly, had it not been doubled but tripled, so rather than writing d, now I will write 3d, and by making it whole square, when I will open it, I will get 1 upon 9d square. So, it was initially 1 upon d square, by making it triple, then the force of attraction between them will become 1/9. The impact is coming on force calculating the square of the change, clear. Now, the third part is the masses of both objects are doubled. The masses of both objects are doubled. So, quite simple, the mass of first object is doubled, that is 2 m1, the mass of second object is also doubled, that is 2 m2. So, 2 and 2 additionally is multiplied. So, if the force initially was G m1 m2 upon d square, then by making a change, by multiplying it, doubling it, 2 m1 into 2 m2 divided by d square, because the gravitational constant and the distance remains the same. Same, it is only the masses that we are doubling up. So, it becomes F is equal to G into 2 and 2 is 4 m1 m2 upon d square. So, ultimately by doubling the mass of both the objects, then the force of attraction between them will be 4 times the original force, right. So, these are the type of questions that may come to you depending upon this particular topic. Now, quite importantly, what is the importance of universal law of gravitation? This universal law of gravitation, this basically explains lot many phenomena, lot many observations that we used to observe in our everyday life. This universal law of gravitation explains all those observations, like where exactly this has been useful. First of all, this has told us that there is a force which binds us to the earth. Second thing, it also explains that why moon is revolving around the earth. Third thing, it has told with context to moon, it actually proves the motion, it relates the motion of all the planets around the sun, and it also explains about the tides, right. You must be aware that there is a high tide and the low tide. Now, why does that high tide and low tide occur? Basically, while moon is revolving around the earth, it is not in an exact circular orbit, but it is in an elliptical orbit that a particular object, a celestial body moves, right. This we will just explain further in a few minutes, right. So, this moon, when it reaches to a point which is the nearest distance to the earth, then because of the gravitational pull of the moon, the water, it rises up, but because of once again the gravity of the earth, it comes back. That rise in the water level due to the gravitational attraction of moon, that is known as high tide, and vice versa, that is when the moon is at the farthest distance, then in that case the gravitational pull is so low that now the water level decreases, that is basically known as low tide. So, the formation of tides in the oceans and seas, that is also explained by universal law of gravitation. Got it? So, this is all about our universal law of gravitation, which is also known as Newton's law of gravitation. Alright, let us see the next question. Now, in this question we are being asked that calculate the force of gravitation between the earth and the sun, given that the mass of earth is 6 into 10 to the power 24 kilograms and of the sun is 2 into 10 to the power 30 kilograms. So, let us see what exactly is given to us in the question. Let us take the mass of earth to be me, which is given to us to be 6 into 10 to the power 24 kilograms, and let the mass of sun be ms, which is given to us in the question to be 2 into 10 to the power 30 kilograms. Now, the average distance between the two is, so the distance between the sun and the earth is given to be 1.5 multiplied by 10 to the power 10 to the power 11 meters, right. This is the distance given to us. Now, we know that the formula to find force is G into m1 into m2 upon d square. The value of G being a constant, we already know that it is equal to 6.67 into 10 to the power minus 11 Newton meter square upon kilogram square. Alright. And putting the other values which were given to us in the question, the mass, the first object is earth, the second one is the sun. The mass of first object, that is the earth, is given to be 6 into 10 to the power 24 kilograms multiply by the mass of the second object, that is the sun, is given to be 2 into 10 to the power 30 kilograms divided by the square of the distance. The distance given to us between the sun and earth is 1.5 multiplied by 10 to the power 11, and since we have to take the square of it, so let us multiply it 2 times, right. So, these are the values that we have put up. Now, the second step, as I have already told you in the previous questions, will remove the decimals. So, that decimal being removed, I will multiply the denominator with 100. These 2 decimals being removed, I will multiply the numerator with the 100. This 100 I can directly cancel out with the 100 down. Now, I will take the numeric values at one side. It becomes 667 multiply by 6 into 2 multiply by 10, the powers of 10 to be taken at one place, 10 to the power minus 11 multiply by 10 to the power, I can just 10 to the power 24 and 10 to the power 30 I can take together, divided by once again the numeric values 15 multiply by 15 at one place, these 2 values, and 10 to the power 11 and 10 to the power 11 at another place, right, on one side. Now, what I will do is I will take these 10 to the powers in the numerator, keeping this value same, 667 into 6 into 2 multiply by 10 to the power minus 11 into 10 to the power 24 into 10 to the power 30. Now, these powers when they go up, they become 10 to the power minus 11, again 10 to the power minus 11. This concept we already know, that whenever the 10 powers are raised up in the numerator, it will be in minus, it will become inverse, divided by 15 multiply by 15. Now, what will I do? I will add up all these powers, and when I will add up all these powers, what I will get is, this is 10 to the power minus 11 and minus 11, this comes out to be 33 in minus 24 and 30, if I will add up, it will become 54. So, 33 at one place minus 54 in plus. So, I will get 10 to the power 21 as a whole net shell. Then I will get 667 multiply by 6 divided by 15 into 15. This when I will calculate up to 2 decimal places, it will come out to be 3.57 multiply by 10 to the power 22. Actually, it was 35.7 into 10 to the power 21. I have just taken it to be 3.57 into 10 to the power 22, or you can take out to be 35.7 into 10 to the power 21. Now, this is the force that we are calculating. So, the SI unit of force is Newton. So, therefore, the value of the force of attraction between the earth and the sun is 35.7 into 10 to the power 21 Newton, or 3.57 into 10 to the power 22 Newton. Clear? Fine. It is all importantly putting the values in the formula, and then you just need to remember that you need to be cautious while doing the calculations. This question just requires calculation, that is it. Fine. So, this is all about the force of gravitation and the formula and the numericals based on it. The force that is exerted between any 2 objects in the universe, the formula which was given in order to calculate that force of attraction. We saw the formula was F is equal to G m1 m2 upon d square. We understood how G came into existence, what is G, what is the normal value of G, and what was the unit of G. Then m1 m2 represents the masses of the objects, d represented the distance between the objects. How? By increasing the masses or by decreasing or increasing the distance, the force of attraction between 2 objects will be impacted. Got it? So, this is all about universal's law of gravitation. I hope you have understood it. Fine. Please try to practice the question. One numerical comes from this topic. This is quite important, and try to study thoroughly. Thank you very much.